I was looking at the idea of increasing complexity. So with digital fabrication, we're able to work at increasingly dense ways of addressing the material. And the question that I was asked is how we develop systems for organizing these sorts of descriptions, or how do we make models that are able to deal with that level of complexity, and especially how we could work with nested systems. So this idea that rather than only having one sort of meta system that could construct the overall, then how do we create subsystems and how do they actually communicate with each other? Our cluster was called Performing Skins, and what we're looking at is material specification. So the idea that what happens when architects become the makers of materials as well as the makers of artifacts. And there what we were doing is looking at textiles as a model for thinking this. So really what happens the moment when we're generating the materials at a very microscopic level. So here the scale of a stitch. And here what we were doing was we were building our own bespoke interfaces between a CAD environment and a CNC knitting machine. We use knit because it's a very quick technique and you can very quickly very easily get results from it. And then being able to write the machine code directly from the CAD environment that controls your knitting machine. And here it's important to remember that the textiles that we're making are models for thinking. They're not ideas that we would actually use. They're not applicable materials in that way. Computation is everywhere. The idea that architecture, there would be a non-computational architecture doesn't exist. All buildings are built through working on computers. The important thing about our field is to understand how we can work with computers to be able to develop better buildings.